So those four equations are really useful for all kinds of equilibrium problems in the two-sector world. You can describe any kind of effect that you might think of. Okay? So for example, we could think about what does the industry elasticity of demand for labor look like? Okay? How would we describe the industry elasticity of demand for labor? How would we use those four equations to describe the industry elasticity of demand for labor? Yeah, with respect to the wage. That's what we mean by that. Whenever economists just say the elasticity, they always mean the own price elasticity. Whenever we're talking about cross-price elasticity, we'll refer to a cross-price. So whenever anybody's saying the elasticity of demand, we usually mean own price, but that's correct. What is the industry elasticity of demand for labor with respect to the wage? How would we use these equations to solve it? Well, first off, you got to ask, well, what's going on with capital? What are we assuming about capital? What's the most typical assumption we make when studying demand for one item? We hold the other prices constant. So let's do that one first. So let's set delta R equals 0, which you might think of in our prior discussion. That might be what you call the long run. Capital's variable here. You freely vary capital as much as you want at the same price. Call this long run. Okay? So our four equations become delta P equals what? What does my first equation become? SL delta W. Delta Y equals epsilon D delta P. Left-hand equation becomes delta L minus delta K equals minus sigma delta W. And my last equation is still the same as it was. Delta Y equals SL delta L plus SK delta K. All right, those are my four equations. How many unknowns do I have? I got to determine what? What's going to change as I change the wage rate? Well, out price is going to change, output's going to change, and labor and capital. So I got the right number of equations and the right number of unknowns. Okay? Let's put these two equations together. What do we get? We get delta Y equals SL epsilon D delta W. So it's easy to get the change in output right off of there. That is, the change in output is going to be, well, the wage goes up 10%, labor share is 0.6, so the costs go up 6%, whatever that elasticity of demand is, say it's minus 2, output's going to go down 12%. Right? So people see that? This is what we call the scale effect. That is, in this industry, there's going to be less output. Why is there less output? There's less output because labor costs went up. That's going to raise product prices. That's going to cause output to fall. Right? So a union comes into this industry, jacks up the wage rate rises, prices of output rise, output's going to fall. That's kind of the idea in mind. Okay? How much? Well, how much it raises the output, how much it lowers output depends on labor share as well as the elasticity of demand. Okay? All right. Any questions that people have? Okay? Okay. Anything before we go forward? How about this equation? Anybody think of a useful way to rewrite that equation? Anybody got an idea how you can rewrite that equation? I've never taught it this way, but I think I see how to do it. What if I were to say, rewrite this equation as delta y equals delta L plus sk delta k minus delta L. Does that look right? Did I do that right? Right? People understand that equation? That implies delta L equals delta Y plus sk delta L minus delta K. I think I did that right. Did I do that right, Casey? I think that's right. It says the change in labor is going to be that scale effect plus whatever happens because they substitute labor capital for labor. Right? Right? But what is delta L minus delta K? It's minus sigma delta W. Okay? And what is delta Y? Delta Y is what? Well, we already determined delta Y right here. So I get delta L equals epsilon D delta, SL epsilon D delta W plus SK times delta L minus delta K, which is what? What is that? Minus sigma delta W. Okay. So first thing you'll notice that both of these are negative, right? This is a negative number. And this is a negative number. So delta L equals SL epsilon D plus SK minus sigma, whole thing delta W. So that's going to be the elasticity of demand for labor.